Hello guys, welcome to the DMS Online School YouTube channel. If you are new to this channel, you are most welcome. And on this channel, I teach mathematics, biology, science, and also revise past examination videos, or rather past papers, just as I'm doing now in this video. Alright, I also offer predictions for science and the biology. Alright, so if what I do on this channel is what you are interested in, please consider clicking the red subscribe button below and also turn on the bell notification so that whenever I upload a new video like this one, YouTube will be able to notify you, because without doing so, it will be very hard for you to see any new video that I'm going to upload on my channel. Alright, so in today's video, we are going to revise this paper which was written in 2022. So the paper reads: Examinations Council of Zambia, Examination for School Certificate Ordinary Level, Science Paper 2. Alright, so 12th November 2022. So without further ado, let's go straight into the revision. Alright, so we have question number 1 here from section A, which reads: which of the following best describes why a factory manufacturing pesticides should be located far away from human settlement? Alright, so they are saying pesticides A are poisonous, B contaminate the environment, C destroy buildings, D may kill animals. Okay, remember in section A you are providing the best answer to the question. All right, so when we look at why manufacturing factories for pesticides are located far away from settlement, here when they say the reason is because these pesticides are poisonous, yeah, they are poisonous, but by locating the factory far away from settlement, human settlement, will not stop them being poisonous. They will remain poisonous. So there's a reason why they're doing that. So like B, contaminate the environment. Pesticides, they do contaminate the environment, yes. And here, destroy buildings. We have no evidence to support this claim that pesticides destroy buildings. All right, then we have may kill animals. Yes, they do kill animals, but that is not the main reason. The main reason is that these are located far away from human settlement so that they do not contaminate the environment in which human settlement is found. So here the best answer is A. All right, then when we move to 2, they're saying which of the following is not a basic unit of matter? Which of the following is not a basic unit of matter? Yeah, so we understand that we have 3 basic units of matter, which are known as atoms, ions, and molecules. All right, so among those 3, which one is not a basic unit of matter here? It is electrons, so our answer is B here. All right, so let's proceed to question 3. Question 3 says, which of the following shows the best order of obtaining salt from a mixture of sand and salt? So here they are testing you on a concept of separation techniques, and the separation techniques that function in separating salt and sand, notwithstanding that salt is soluble in water and the sand is not soluble. So they are trying to make you choose a method that will be able to separate a mixture of sand and salt. All right, so which of the following is the best? The same one: dissolving, filtering, and evaporation. All right, so yeah, for you to be able to separate sand and water, you require to dissolve it. All right, so that salt can dissolve while sand cannot. Then the saying filtration. So if salt dissolve in water and sand does not, then you can separate the two by filtering, which is true. Then next is evaporation, where now you can collect salt from the water. So yeah, so the best answer here straight away is A. All right, then 4 says the best method of separating iron filings from copper powder is, so we have filtration, flotation, hand picking, then magnetism. All right, so here they are trying to use a separation technique that depends on the magnetic properties of materials. So when you look at the iron filings and copper powder, you must note that the copper is a non-magnetic material while iron is a magnetic material. So in such a situation where you have a mixture of a magnetic material and a non-magnetic material, the best method to separate them is magnetism. So here the answer is D. So we move on to 5, which says, in which of the following are the greatest intermolecular forces? All right. So in which of the following are the greatest intermolecular forces? All right. So intermolecular forces are actually forces that exist between molecules in a compound rather, or in a substance. So a molecular substance, or rather these covariant substances, will contain of small molecules that are held together by what we call intermolecular forces. Now they want us to choose among these the substance or the ones that would lead to greatest intermolecular forces. So intermolecular forces arise from covalent bonding, and that covalent bonding arises from electron affinity, a substance or an atom or element having ability to attract the electron to itself. And the fact that you should know is that the less number of shells a nanometal atom has, the more electron affinity it has, or the more force of attraction it has on an electron. And because of that, the more also the stronger the intermolecular forces that it produces. So in this case, when you compare these, the one with the less number of electrons is fluorine, and these are found in group 7. So fluorine is at the top of the group, and it has less number of electrons and less number of shells, and because of that it has more electron affinity, and because of that it can lead to the more intermolecular forces. So here the answer is C. Then A6 says the following dot and cross diagram represents a compound. Okay, so we have a cross and a dot compound, which is of a compound. Then they're saying identify the compound shown in the diagram. The compound is, so here when you see these are electronic structures of a compound, and they are showing the ions that have been formed in this compound. So when you look at this atom here, or rather ion, it is charged positively, and for you to be able to identify the compound here, you must identify this atom and this atom. So how? By counting the number of electrons in this atom, and also once you know the number of electrons in this atom, you will be able to know what an element it is. So like this one, it has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this plus here, it means it lost 2. So plus those 2, then that means it will have 12 electrons, and an element which have 12 electrons is magnesium. Then this one here, it has a negative 2 charge, which means it gained 2 more electrons to make it to somewhere 10. And for us to identify it, we need to know its own electrons. So these are its own electrons, which are 1, 2, 3, 4, 5, 6, 7, 8. So we will also check the atom which contains 8 electrons, and in this case is the oxygen. So if we have magnesium and oxygen, the compound they form is called magnesium oxide. So in this case, our answer is B. All right, then we move to question 7, which says, which of the following liquids, when added to a strong acidic solution in the correct amounts, could produce a solution with pH of 7? All right, so A, we have like distilled water, ethanoic acid, lime water, potassium hydroxide. Yeah, so if we have a strong acidic solution, for us to bring, because we know a strong acidic solution have a pH value ranging from 0 to 3. Now for us to bring this pH of this strong acid from somewhere 0 to 3 to 7, which is a pH for a neutral substance like water and salt, we need to neutralize this acid here. And since it's a strong acid, we need to neutralize it using a strong base. Alright, so in this case, the strong base that we can use here, distilled water cannot neutralize it, ethanoic acid cannot neutralize it, lime water is a base, but this is calcium hydroxide, but it is not a strong base that can neutralize an acid to bring it to the pH of 7, but potassium hydroxide is a strong base that can neutralize a strong acid to bring its pH to 7, because once such a reaction happens, there's salt and water that is formed, and these salt and water, they have a pH of 7. So our answer here is D. All right, then A8 says, what is the identity test of the gas produced when an acid reacts with a carbonate? So here again, they are trying to test you on the properties of acids. All right, so one of the properties of acids being tested here is that of acid reacting with carbonates to produce a salt, carbon dioxide and water. All right, so now that carbon dioxide that they produce is what they're asking its identity. They're saying, what is the identity test of the gas produced when an acid reacts with a carbonate? So that gas, like it puts off the burning splint with a pop sound, no, relights the growing splint, no, turns lime water colorless, no, turns lime water milk, yes. So carbon dioxide turns lime water milk. So that is the identity test for carbon dioxide. Okay, so our answer is D. Then we move on to 9, which says 25 cubic centimeters of 1.0 mole per cubic decimeter sodium hydroxide solution are measured into a 100 cubic centimeter volumetric flask and water added to make the solution up to the 100 cubic centimeter mark. Then they're saying the concentration of sodium hydroxide in this solution is, all right, so here again you need to pay much attention, because what they're saying here is that you have a volume of or you have sodium hydroxide solution of volume 25 cubic centimeters and then concentration of 1 mole per cubic decimeter. Then this is gotten, all right, and then added to a volumetric flask that holds the maximum capacity of volume of a liquid up to 100 cubic centimeter. Then they're saying when it is put in that volumetric flask, water is added to it until the level goes to somewhere 100 cubic centimeter mark of that volumetric flask. Then they're saying the concentration of sodium hydroxide in this solution is what? So they're asking after it has been diluted, because this concept they are testing you is from dilution. All right, so you need to know the law of dilution here. So the dilution law operates on this chemical formula here, on this formula here, where we have like concentration before dilution represented by 1 times volume before dilution is equal to concentration after dilution times volume after dilution. So I want to make you understand this situation very well. So in the first situation, we have like a volumetric flask in which they put first they add these 25 cubic centimeters of 1.0 mole per cubic decimeter of sodium hydroxide. Here they add it there in a volumetric flask, okay, and its volume is somewhere 25 cubic centimeters, and then the concentration here is somewhere 1.0 molarity or mole per cubic decimeter. So now this is what we have now. After they've put it here, they now do what? After dilution, so they add water to it so that it should reach to that mark. So now after that, this is it, they add water to it, it reaches up to that mark. Now they're asking you, after it reaches up to that mark, like they've filled it up to that mark, they're asking you for concentration here. So concentration now will be found using this formula here. So you must understand that they filled this up to the volume of what? Of V2. So this is V2 now, volume 2 here, which is now 100 cubic centimeter, because that's the level to which it went, because they said water added to make the solution up to the 100 cubic centimeter mark, like that. So they want now the concentration in here, so we use the dilution formula to do that. So we'll start substituting, like where we have C1, we have 1, we substitute there 1 times V1, which is 25 cubic centimeters. So in this case here, we usually don't worry about units because they cancel themselves out. So here we'll put 25, which is going to be equal to, so here concentration 2 is what we are calculating, so we'll put as it is in terms of volume, which is 100 cubic centimeters, like that. Then since we want this C2, so we'll divide by 100, even this side by 100, so that this 100 and this can cancel very well, so that will remain with this C2 is going to be equal to, so what we are going to do here is this. So like if we got the calculator here, so let me just get the calculator here and show you what will happen. Like 1 times C 25, then like equals, then like divided by 100 there, like what do we get? Like we get 0.25. okay, so meaning our concentration becomes 0.25 molarity or more per cubic decimeter. So in this case our answer is going to be A. All right, then we move to 2. So I mean 10 says what mass of sodium carbonate with this formula here is required to make a 250 cubic centimeter solution whose concentration is 0.3 molarity. All right, so what they're asking us here is to again take note of the mass of calcium carbonate. So this calcium carbonate is going to be made into a volume of 250 cubic centimeters, and that volume will have 0.3 concentration of calcium carbonate. So now they want how much mass should be in order to form a volume of 250 solution of calcium carbonate and have a concentration of 0.3 molarity. So you know mass is what they want, and we should first of all look at a formula which connects mass in more concept. All right, so here we have this formula which says number of moles is equal to mass over molar mass, and they want this mass here, that's the one they want. So mass is equal to number of moles times molar mass, number of moles times molar mass. So in this case, what we need to find this mass is the number of moles of calcium sodium carbonate, and also molarity of sodium carbonate, which is easy. Now how can we know the number of moles of sodium carbonate? We should see that we have been given a volume, and also we have been given molarity, which is concentration. So meaning we are going to use these two to come up with the number of moles using the formula which says concentration is equal to number of moles over volume. And if we make number of moles the subject of the formula, we are going to have number of moles is equal to concentration times volume, and then we'll come to data here. You see we have data, the information that we are going to plug in our formula in order to find the answer. So like we have concentration, which is 0.3 molarity, and then we have volume, which is 0.25 cubic decimeter. So we have converted this one. In this case we did not convert, but this is the case where you need to convert this one into cubic decimeter by dividing by 1000. Like so, if you pick like 250, there you divide by 1000 so that it changes to cubic decimeter. You find that your answer is going to be 0.25, just as we have found here. All right, so having found these, now you substitute, like you say, equals concentration, you put 0.3 times volume, which is 0.25. when you multiply these, like here, let me just show you, like 0.3 times 0.25, you get like 0.075. so here the answer is going to be 0.075 moles. So these are the number of moles now here. So the number of moles of sodium carbonate that will be in the solution are these. So that will be needed. So we'll know now that the number of moles, we know, we'll substitute here number of moles, we'll put this value here, 0.075 times then molar mass for sodium carbonate. So like you check sodium, when you check on the periodic table, like it has 23, all right, then carbon has 12, then oxygen has 16. So if you total these, you are going to discover that let me just try to show you something. So like in this case, sodium, I will say open brackets. Okay, let me just cancel everything. I'll say open brackets. Sodium, I know that it has 23. So 23 as the mass for sodium, one sodium atom. Now here there are 2, so you say by 2. Okay, then you close, then you say plus. So carbon here has 12 as its mass, so I'll say plus 12, then plus. Then I'll come to oxygen. Oxygen has 16, but there are 3. So you say 16 times 3, because there are 3 of them. Then when I say equals, I'll find that it will be like 106 as the molar mass for sodium carbonate. So meaning I'll substitute here and say 106. Then when we multiply this times 106, so I already have 106 on my calculator, so I'll just say times 0.075 and get 7.95 as the mass. So the mass here will be like 7.95 grams. So in this case, I'll check my best option here is B. So our answer is B. Then we'll move to question 11, which says an experiment was carried out as shown in the following experiment diagrams. Okay, so we have experiment 1 and 2. So in experiment 1, we have a beaker filled with water to the volume of 8 cubic centimeters, and then we have 5-gram lump of sodium metal placed here. Then in experiment 2, we still have water as well filled to the same capacity of 8 cubic centimeters, and also placed on it is 5-gram pieces of sodium metal. Now the question says, where was the reaction faster? All right, so the concept being tested here is, or rather the question is coming from rate of chemical reactions, and the concept being tested here is the size of particles. All right, so remember in chemical reactions, and if we are dealing with solids like sodium metal, which is in solid, so solid deals with particles. So the smaller the particles, the faster the rate of reaction. So if we have 1 lump of sodium metal here, and then we have, which is 5 gram, then you have these pieces of sodium metal that are all in a total, they are 5 grams. Okay, they are 5 grams in a total. All right, then which one will go faster? So according to the factors that affect rate of reaction, we say the smaller the particles, the faster the chemical reaction. So between the two, this one, the particles are smaller, so this reaction will be faster. So our answer is going to be B. All right, so let me just give you a quick recap. So we are saying factors that affect rate of chemical reactions. So these are: one, size of particles, which is the one this question was based on. So size of particles, what you should know is that affects only reactant in solids, like this sodium metal, they are in solids. Then another factor that you should remember is concentration. All right, so concentration here we are saying affects only reactants in liquid and gaseous state. All right, so another factor which affects the rate of chemical reaction is pressure, and pressure affects only reactants in gaseous state. Then another factor is temperature, which affects all reactions or reactants. Then we have also catalyst, and this affects all reactants. All right, so now let's go to question 12. Okay, so question 12 says, which of the following best explains why hydrogen H is not placed in any group on the periodic table? So you must have noted that if I were to get the periodic table, let me see if I can get the periodic table quickly. The periodic table, the periodic table. Okay, so if I were to get the periodic table, you must note that the hydrogen is placed alone on this periodic table here, and this is why they're asking us, okay, to say why is it that the hydrogen is placed alone here on the periodic table instead of any of these groups. All right, so simple. So here they're saying it has no neutrons. No, this is not the main reason. Then B, 1 electron in its shell, which is true, but it's not the main reason. Then C, properties of both group 1 and group 7 elements, true. So the main reason hydrogen is put alone on the periodic table is that because it is found to have like properties of group 1 and properties of group 7, so they can't put in any of these, which means it will be conflicting other characteristics of elements found in that group. Hence it was put alone on the periodic table. So the answer here is C. Right, so here they say properties of most of the elements, no. Then we come to 13, which says the atomic symbols of elements W and Z are as follows. So we have W here, this is it, and then Z, this is it. Then here they're saying the base units of the following of the compound formed by W and Z are. So the base units of the compound formed by W and Z are. So first of all, before you know even the basic units, first of all you need to identify what is element W. So element W has atomic number 19. So if you come to the periodic table, which is always found in the exam, you find that it is potassium with atomic number 19 there. All right, then when you come also to this element Z, you find that the atomic number is 17, and similarly if you come here you find that the one with the 17 is the chlorine here. All right, so meaning this potassium is a metal and this chlorine is a non-metal. All right, so now if these two react, they form a compound. Now the type of a compound that is formed when a metallic atom and a non-metallic atom combine is an ionic compound. An ionic compound consists of ions as basic units. So here the answer is B, so ions. All right, so let's move to question 14, which reads elements X is less dense than water and reacts fast with cold water, liberating a gas. Which details are correct about element X? Okay, let's read again. They're saying element X is less dense than water and reacts fast with cold water, liberating a gas. Which details are correct about element X? Alright, so we have element X in equation here, and we are told this element X is less dense than water and reacts fast with cold water. So reacts fast with cold water, liberating or producing a gas. Then they're saying which details are correct about element X. So when we come here, we have name of element, then we have a period, then we have type of solution, then we have gas, then we have gas produced, yes. So that element, first of all, which is less dense than water, and then reacts with cold water, liberating liberating a gas. You must understand that such an element which reacts with water should be, first of all, a metallic element. All right, so X in the first place is a metallic element. And for it to react with cold water, it must be a very reactive metallic element, and it must be found in group 1 of the periodic table. And then when it reacts with water, you must know that the solution formed should be an alkali or a base, and the gas produced should be a base, a hydrogen, I mean. So when we come to here, name of element, we have beryllium, which is in group 1, cesium in group 2, calcium, in group 1, then calcium in group 2, sodium in group 1. So this one right away we cancel it because it does not have such properties, but we remain with this one. Even beryllium we cancel it because it is said not to react with cold water, I think, if I remember very well. Then when it comes to period, we'll check is beryllium found in period 2? Before we even go to this, if we quickly move to this one here, type of solution, beryllium, does it form acidic and then produce that one? This one is wrong. So this one right away is already wrong. Then when we come to cesium, does it form neutral and hydrogen gas? No. So this one right away is wrong. Then this one we already cancelled it. Then sodium, is it in period 3? When you look at sodium, put these electrons of sodium, because this is the nuclide notation of sodium, and this shows the structure of sodium in its the composition of sodium atom in totality. So it has 11 electrons which can sit as these 2, 8 and 1. So 2 in the first shell, 8 electrons in the second shell, and 1 in the last shell. So there are 3 shells, and you must remember that the number of shells in an atom is equal to the period in which it belongs. So here there are how many shells? 1, 2, 3. So yes, sodium is in period 3, and then I say that reactive metal, when it reacts with cold water, it should produce an alkali solution, and yes, type of solution alkali, and I said the gas that should be produced should be hydrogen. So in this case our answer is D. Okay, then 15 says the following diagram shows the ionic lattice of a substance. Okay, let's move to the next slide. Okay, so the following diagram shows the ionic lattice of a substance. So this is an ionic lattice structure of a substance. Okay, then they're saying what is this substance likely to be. All right, for you to be able to show this, to know this substance, you must understand that it has got this atom or ion which is negatively charged, or which has a negative charge of 2. So if it has a negative charge of 2, meaning this ion is a nanometal, and it gains 2 electrons to become stable. Then also we have this ion with a positive charge of 1, and if it has a positive charge of 1, that means it is in it loses one electron to gain this positive charge of 1. And another concept that you should know is that then it is in group 1, and this one which gains 2 electrons to become stable is in group 2. All right, now let's see if we can see which one are these. So this one should be in group 8, rather 6 I mean, and then this one should be in group 1. All right, so what is the substance likely to be? So if they're saying magnesium, which is a metal, but magnesium is not in group 1, so this one is wrong, and this one still magnesium is still wrong. Then they're saying sodium. Yeah, sodium is in group 1, yes, and forms a positive charge of 1, yes. How about chlorine? Chlorine is in group 7, and chlorine is in group 1, and it requires 1 electron to become stable, and it forms a charge of -1. So in here it does not qualify. What about here? Sodium qualify. Oxide, which is oxygen, yeah, oxygen is in group 7, and it requires group 6, and it requires 2 electrons to become stable. So this means that this substance here is sodium oxide. So our answer is D. Okay, so then let's move to another question, which is question 16, which says the flow chart shows a commercial manufacture of slaked lime. So this flow chart here shows a commercial manufacture of slaked lime. Okay, so they're saying before that, okay, they're saying what is condition J and substance R, substance K. Okay, so we have limestone. Limestone undergoes condition J, forms quicklime. Quicklime to it added substance K forms slaked lime. Alright, for you to understand this procedure, let me just open you up. You must understand what limestone is. So limestone is also known as calcium carbonate. So the chemical name of limestone is calcium carbonate, and this quicklime here is also called calcium oxide as the chemical name, and this slaked lime here has the chemical name as calcium hydroxide. Now if you have limestone, which is calcium carbonate, like let me demonstrate here. We have calcium carbonate as the symbol for calcium carbonate. This is the chemical formula. So for it to turn into quicklime, you have calcium carbonate, which is this one here. For it to turn into quicklime, it means it must have been heated. All right, it must have been heated for it to undergo decomposition reaction. So it must have undergone decomposition reaction after heating it, so that it forms quicklime, which is calcium oxide here. Calcium oxide here, and not only does it form calcium oxide, this process forms also carbon dioxide gas. All right, now after you have formed like calcium oxide in this form, now they're saying this calcium oxide with substance K produces slaked lime. So like, okay, if we pick calcium oxide here plus what substance does it react with to form slaked lime? That substance should only be water. All right, so that should be water, so that when calcium oxide reacts with the water, forms the calcium hydroxide like that, which is this one called slaked lime. So now when you see this one becomes our K, all right, and this one becomes our J. All right, so meaning when we come to the question, what is condition J and substance K? So condition J is heat and K is water, so the answer is C. All right, so let's move to question 17, which says which of the following shows the correct method of collecting of which of the following shows the correct method of collection of a dry sample of each of the named gas in the table shown? All right, so we have like a gas ammonia, carbon dioxide, and hydrogen. So and we have provided the method for each. So for you to be able to answer this question correctly, you must remember the the properties of the physical properties of each of these gases, and then secondly the methods of collection. So you must remember that here sodium, like ammonia is a very light gas and also soluble in water, and it is collected by upward delivery. Like this it is collected by this upward delivery because it has less density. So these are one of the methods. Then carbon dioxide, one of the properties of carbon dioxide is that it is soluble in water and also denser than air, and because it is denser than air, it is collected by downward delivery or downward displacement of air. So you see that we are already moving here, nothing really matches. So when we come here, hydrogen is the lightest gas known. So because it is very light, it is actually collected by upward delivery method. So I find that our answer is right away D. Then 18, we are saying an unsaturated hydrocarbon with 6 carbon atoms contains only 3 carbon to carbon double bonds. This hydrocarbon is reacted with excess hydrogen at a high temperature. So what is the formula of the resulting hydrocarbon? Yeah, so what they are saying here is that there is an unsaturated hydrocarbon. So this is the organic chemistry, guys. All right, so now let me take this opportunity to actually tell you that there is a revision package for science paper 1 and then science paper 2 from 2015 to 2022, and this revision package contains videos just like this one from the first question to the last question, which shows you how to answer literary exam questions like the way I'm showing you now. Why am I even telling you this? I'm telling you this because most of the problem that you guys face in answering exam questions is because you have less exposure to exam type questions and how to handle or rather answer those exam type questions. And I formulated this package to help students pass science with a distinction 1, because as much as they revise in these past papers which I've answered myself, they are going to have their brain preoccupied with the information about how and how each and every topic about a particular how each topic is questions come in the exam, and how those questions are answered, okay, and how concept that you learn in class are applied in answering exam questions, or how those concepts how questions from the concepts you have learned in class questions are said from those concepts, okay. So it's very important that if you want to get a distinction, you get this revision package at 120 kwacha. It was 60 kwacha, now it is at 120 kwacha. And remember, the knowledge you invest in, it is going to pay you more and more in the future. All right, other than that, I also have bonus videos that I'm going to give you. Like I can give you organic chemistry lessons, and also more concept lessons once you get that revision package, and the radioactivity as bonus videos that are going to help you. Yeah, so if you are interested, the number is on the screen that you should just use to contact me, so that you get the revision package at 120 kwacha, so that you write your exam, or you pass with flying color, and you don't repeat in a GCE. And if you are GCE also, you can jump on that also, take advantage of it, so that you revise and pass in your coming exam in July, August. All right, so having said that, let's go and answer this question. So we have an unsaturated hydrocarbon with how many? 6 carbon atoms. So if it has 6 carbon atoms, they are saying contains only 3 carbon to carbon double bond. So you have an unsaturated hydrocarbon like an alkene. So it has 6 carbon atoms, like 6, like 1, 2, 3, 4, 5, 6. Then they're saying it has 3 double bonds, like maybe here you have a double bond, maybe here single, here double, here single, here double. All right, and remember, a hydrocarbon contains carbon atoms as the central atoms and then surrounded by carbon atoms. So like here there'll be like these bonds to which carbon atoms should be added. I mean hydrogen atoms should be added. Like here there'll be hydrogen, 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 hydrogen. Now the format I've used to know that this is how it is going to be is to make sure that each carbon in the center is surrounded by 4 bonds. Like this one has got how many bonds? Like 1, 2, 3, 4. This one also has got a 1, 2, 3, 4. This one also has 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 1, 2, 3, 4. So this is how this hydrocarbon here is. All right, now they're saying this same hydrocarbon here, this hydrocarbon is reacted with the excess hydrogen. So meaning it is reacted with excess hydrogen like that. So hydrogen is written like H2. All right, so now I've decided to break it into structural formula like this. So H, this is how it is bonded, one hydrogen bonded to another like this. So now this is how it is bonded. Now if this is reacted with this, remember hydrogenation is going to occur where one of these bonds, double bond, is going to break. When one of these double bond breaks, this is going to be added, the hydrogen atom will be added. So this one has 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atom, then to it there will be added 2 more. So this is how it is going to occur. So the double bond breaks and then these are joined. Now the question says, what is the formula of the resulting hydrocarbon? So this is the resulting hydrocarbon. So the formula should have how many carbon should be just the way they were, carbon atoms 6, and then hydrogen atoms should be 10, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the one which has 6 carbon is this one, and the 10 hydrogen atoms is this one. So the answer is B. Okay, then we move to question 19, which says the reactions listed all involve ethanol. The reactions listed all involve ethanol. All right, so we have reaction 1, 2, 3. So here we have ethanol plus oxygen. It gives us the ethanoic acid plus water. Then to here we have also ethanol as well. Okay, or involve ethanol. Yeah, so here we have also ethanol plus the ethanoic acid. So it's like we are having ethyl ethanoate plus water. Then here we have like a glucose, then which gives us the ethanol plus the carbon dioxide. Then they're saying which row correctly describes each reaction. So we have 1, 2, 3. So they are saying reaction number 1, like here where we have alcohol plus ethanol plus oxygen, we form like ethanoic acid plus water. So they're saying like this type of reaction is what? Combustion? No, this is oxidation. So we come here, so oxidation and oxidation here. Then we come to 2 where we have ethanoic acid, ethanol, and then ethanoic acid forming ethyl ethanoate, which is an ester, this one here. So this reaction here is called esterification, esterification, which is this one here. Okay, so we are already almost there at the answer. Then when we come to the last one, 3 here, we have glucose, and this glucose turns into ethanol and the carbon dioxide. So this reaction is actually fermentation. So fermentation. So our answer is D. All right. So let's go to 2020. So 20 says state the following organic compound. Study the following organic compound. So we have this organic compound here with how many carbon atoms? 1, 2, 3. So which means this is propene because it has a double bond and it is an alkene. Then the saying why is the compound shown able to decolorize the bromine solution. All right, so remember when you are studying hydrocarbons you must come across this property of alkenes which says they are able to decolorize bromine solution or liquid, and the reason is that they have a double bond here. So this double bond behaves like stored energy, all right, or like a kept pair of bond or unused bond, which when reacted with the bromine breaks, and then that bromine is added to it to form like a bromo, like this one it should be bromo propene, something like that. So that one now will not have that color. So the main reason why it is like that, we are saying it can dissolve in bromine, no, has double carbon to carbon bond. Yeah, that's the main reason here. So the answer is B. Now we move to section B here, 45 marks. Answer all questions in this section. Write your answers in the spaces provided in this section paper, in this question paper. Yeah, so guys, again, let me take this opportunity for those of you that wants to learn how to be able to answer science questions, and like chemistry, you become a pro at answering past papers, like for science paper 1, paper 2, so that you can get a distinction. If you want online lesson for grade 12, they are available. I'm teaching science, mathematics and biology. All right, so you can just contact me on the number that is appearing on the screen, and then I'll be able to add you to the online lessons. Of course, it's not for free, and of course, to everything that you'd like to acquire, there's a cost that you have to pay. And in this case, science, you have to pay 120, and then mathematics 60 kwacha, and then biology 60 kwacha. All right, so if you are a GCE student and then you want to learn some online lessons, you can join me. And also if you are a grade 12 student and then you want to at least understand more concepts before you write the exam, and then you are also welcome, you can join the online lesson for the same prices. All right, so the number is the one that is appearing on the screen. All right, so let's start answering this question, like B1A1, which says part 1, which says give one reason why laboratory rules are very important. So here we need to give one reason why laboratory rules are very important. So this is the rule why they are important. So number 1 is that laboratory rules are very important for ensuring safety in a laboratory environment. Yeah, that's why laboratory rules exist. They exist to ensure safety in the laboratory environment. All right, then in part 2 of A says state one importance of chemistry in our day-to-day life. So chemistry has got so many importances in our day-to-day life, but I decided just to give one, like this one, where I said chemistry is important in agriculture industry because it helps us to produce fertilizers and pesticides used in agriculture. Okay, let's go to B. So B is saying the following graphs show heating caves that were drawn after pure ice and candle wax were heated over time to their melting points. Okay, so we have two heating caves. So this is a heating cave. So heating caves just show change of state as a substance is heated with time. So heating caves show the change of state of a substance as it is heated with time. So there are two heating curve, the one labeled X and the one labeled Y, and they're telling you that the graph, the following graphs show heating curves that were drawn after pure ice and candle wax were heated over time to their melting points. Then part 1 here of B says identify the heating curve for the candle wax and give a reason for your answer. So the heating curve for the candle wax is X, and when they say reason, we are saying Y is for a pure substance like pure ice, so X can only be for candle wax. Yeah, so the way they had to put the question like this is how we can explain. So you must understand that pure substance produce actually sharp melting points, either sharp boiling points and then sharp melting point like this one. So this one here, it's a sharp melting point, so meaning this one was actually a pure ice, but this one here has produced a varying melting point here. So this is not sharp, it is just actually varying melting point, and varying melting points are for impure substance. All right, and we were told that this was between pure ice and candle wax. So this candle wax wasn't pure, because if it was, they were going to state. So it means the one which was pure, which is pure ice, produced this, and then this one was produced by candle wax, which is not pure. So this is how you should have or this is how to answer this question. Then we move to part 2 of B, which says give one effect of impurities on the melting and boiling points of a pure substance. So we need to give one effect of impurities on the melting and boiling points of a pure substance. So simple, you must understand that in the presence of impurities in a pure substance generally lowers its melting point and raises its boiling point. Yeah, so impurities would lower the melting point of a substance and then raises the boiling point. Yeah, so let's move to B2. So B2 here says study the following flow chart and answer the questions that follow. So we have like liquid P plus liquid Q mixture, then it forms like mixture X, which has no distinct layer seen between P and Q. Then a separation technique, T separates into P and Q. Then they're saying what are liquids P and Q in mixture X called? Okay, so when you check, you have liquid P and liquid mixture Q that you are mixing to form mixture X, and then they're telling you that when they form mixture X, no distinct layer seen between P and Q, meaning liquid P and Q mix uniformly, or rather they form a homogeneous mixture. Now, for them to be able to form a homogeneous mixture, that means these two liquids are miscible. All right, like when you get alcohol and water, you mix them, you won't be able to see the level at which water maybe is ending and the level at which alcohol is ending in that mixture. All right, like unlike when you mix water and cooking oil, you are able to see the difference there, the distinction. So in this case, they are saying this situation is like that of water and alcohol, where when you mix these two, you cannot distinguish the difference in layers. That's why they're saying no distinct layer seen between P and Q. So now when they say these two, now when they say what are liquids P and Q in mixture X called, so such liquids which mix uniformly are called miscible liquids. Okay, that's what we call them. Then when we come to B, they're saying, what is the separation technique T? Give the criteria used to separate the mixtures. Okay, so we bring back the diagram here. So they're saying these, when they were mixed, they were separated using technique T into P and Q. Then they're asking us to do what? To say what is the separation technique Q here. Give the criteria used to separate the mixtures. So the only separation technique that is used to separate a mixture of two or more miscible liquid is fractional distillation. So the separation technique here is fractional distillation. Then the criteria. So criteria is the property upon which the separation depends. Okay, so the property upon this separation depend is difference in boiling point. So these liquids have got different boiling points, and because of that you are able to separate, or we are able to separate them into their components using boiling points. All right, so let's look at this C, which says deduce the names of liquids P and Q. Like we need to conclude the names, like what is the liquid P and Q. So like here, when they say deduce, it's just to give any liquids that you know which are miscible, and then they can be separated. So in this case, in class, we teach these which are common, like liquid P could be ethanol and the liquid Q could be water. So these are the common liquids that we teach in class, but there are so many liquids out there. Okay, so now let's move to the other part of the question, which is B3. B3 says the following symbol shows a nuclide of element A. So the following symbol here is a nuclide of element A. Then they are saying distinguish between the numbers 16, this one, and the 32, that one, shown in the nuclide for element A given. So what we must understand, that this like 32 here, 32, what we know is that 32 is the sum of the total number of protons and neutrons in the nucleus of an atom, while this 16 is the number of protons in the nucleus of an atom. Yeah, so this is how we can do it. To distinguish, we can just define them, because that's also how they differ. So 32 is the sum of the total number of protons and the neutrons in the nucleus of an atom, while 16 is the number of protons in the nucleus of an atom. Or you can also say 32 is a mass number, and then 16 is a proton number. Then B, part 1 says, to which group of the periodic table does element A belong? So they're asking the group. So for you to know the group in which it belongs, you can also use electronic configuration. Like if this is an atom of element A, it has 16 protons, which means it has also 16 electrons in its neutral state. So such 16 electrons can be placed in shells as follows. Like the first shell should hold 2 electrons, second shell 8 electrons, and the last shell 6 electrons. Now you must know that the number of electrons in the last shell equals to the number of group to which an atom belongs. So since it has 6 electrons in the outermost shell, it means it belongs in group 6. So when they say to which group of the periodic table does element A belong, so you say group 6. Now the beauty about these such type of questions is that you even know if you are wrong or not. So you go to the periodic table, you find that this element with the same, like 16, 32, which group 6. So find that failing these questions is like not possible. All right, that's why I'm advising you to have the revision package so that you can see as many tricks as possible that come in the exam to put you at a better step for you to be able to tackle exam questions. All right, so like part 2 of B, they're saying use the periodic table to identify element E. So using the periodic table, they want us to identify element A. So just as I did, I said you go to the periodic table, find that this element has got atomic number 16 and 32 mass number, which is for sulfur. So element A here is sulfur. All right, so let's move to C. So C1 says draw a dot and cross diagram to show the bonding formed in a compound between element A and hydrogen. Okay, so they want us to show the bonding involved using dot and the cross diagram. So we'll bring element A here, and then we'll put these electrons, because since it has the 16 atomic number, and since it is an atom, it means it has also 16 electrons, which can put in shells as 2, 8, and 6. And then hydrogen, since it is bonding with hydrogen, then hydrogen has got only 1 electron, like that. All right, so that means for this to be stable, this shell needs to gain 2 more electrons, all right, to be stable, and meaning it needs to share 2 more electrons for it to be stable, because the rule of bonding, covalent bonding, is that the number of electron an atom lacks or needs to gain to be stable, it's the number of electrons it can also share. So this one needs 2 more electrons to be stable, so it can share as well 2 electrons. So hydrogen here requires only 1 electron to be stable, and also it will share 1. But since here we need 2 electrons, meaning there will be 2 atoms of hydrogen, each one of them contributing 1. So if we were to put now to draw dot and cross diagram, we'll start with the diagram of this. Like in the first shell, it will have like 2 electrons using dot. Then in the second shell here, it will have 8 electrons, like that. Okay. Then in the third shell, it will have like 6 electrons, like that. Then we'll put A inside as the name. Then hydrogen has just 1 electron, and we'll use the cross here. So this is hydrogen. So plus, they are going to combine. We'll put plus, and then once they combine, they'll form a compound, a single compound. So they will need to share these electrons. So I said this one should share 2 electrons. So for it to share 2 electrons, it must align them like this. So 1 electron will be shared with hydrogen atom, and this one with hydrogen atom. So here there will be hydrogen atom. 1 hydrogen atom will come and share its electron here, and another hydrogen atom will come and share its electron there. And this is the compound that is going to be formed. All right, so you just get 1 mark for this. Then C part 2 says compare the bonding in the compound formed in C part 1 with that in carbon oxide. So they're saying the bonding formed in this compound here, found in this compound here, and the one in calcium oxide, we compare them. So you must understand that the type of bonding which happens between calcium and oxygen, since calcium is a metal, oxygen is a nanometal, that type of bonding is ionic bonding or electrovalent. All right, now this bonding which is here, it is a bonding which happens between nanometals, because we have noted that actually A is the sulfur, which is a nanometal, and reacting with hydrogen, which is also a nanometal. So this type of bonding which involves the sharing is covalent bonding, which happens in nanometals. So when they say we compare, so we'll just say the bonding in AH is covalent bonding, while that in calcium oxide is ionic bonding. Or you can even say the bonding in AH is that type of bonding which involves the sharing of electrons, while the type of bonding found in calcium oxide is that which involves the transfer of electrons from the metallic atom to non-metallic atom. Alright, so let's move to the other part of the question, which is B4. B4 says salts are important substances that have many uses. So A, they're saying describe how a fairly dry sample of lead 2 sulfate can be prepared from aqueous sodium sulfate and a soluble compound of lead in the laboratory. So this question is coming from a topic which is salts, bases and acids. Acids, bases and salts, which have already taught on my channel. Alright, I've taught these topics very well on my channel. You can scroll, and if I'll be able to remember by the time I'll be uploading this, I can even put links in the description so that you can quickly go to those videos if you want. So they're saying now you need to describe how you can prepare a sample of lead sulfate. So this is the salt lead sulfate, and then you can prepare it from aqueous sodium sulfate and a soluble compound of lead. So they want that soluble compound of lead. Now, for you to be able to know what method this should be, this salt should be prepared with, you must know the type of a salt is in terms of solubility. Is it a soluble salt or not? So lead sulfate, lead 2 sulfate is an insoluble salt, and insoluble salts are prepared by precipitation method. Okay, so in the precipitation method, you need 2 compounds or 2 salts, 2 soluble salts, each containing the ion of the salt you are forming. Like in this case, for us to form lead 2 sulfate, we need 2 salts. One salt should contain sulfate, another salt should contain the lead. So we have already been told that one has got a sodium sulfate. Then they've told us that there will be another one which contains the lead. So which one is that? So we need to look for it. So that salt should be soluble, and in that case, straight away we'll look at the lead nitrate. Okay, so now in terms of describing now, or just summarize it, look at the space provided, though 4 marks. So you summarize it like here, like you say, lead sulfate is insoluble and can be prepared by mixing aqueous sodium sulfate with lead 2 nitrate. Okay, so lead 2 sulfate is an insoluble salt and can be prepared by mixing aqueous sodium sulfate. This sodium sulfate they provided with lead. So they provided lead, but that compound in which this lead is found, we chose lead 2 nitrate because it is soluble. Now what happens is that these two mixes, so like sodium sulfate and lead sulfate will mix and exchange ions, like this sodium will pick on sodium nitrate, and then this lead will pick on lead sulfate. So it will be like lead sulfate, like the one they want here. Okay, once you describe that, the first step that you should say again is that the resulting mixture can be filtered and the precipitate of lead sulfate can be dried in an oven after washing it. So you gain 4 marks just in this, because 1, you have stated how this can be prepared. You have stated that lead 2 sulfate is insoluble and can be prepared by mixing aqueous sodium sulfate with lead 2 nitrate. Okay, solution, of course you can add either solution. Then you can say the resulting mixture can be filtered and the precipitate of lead 2 sulfate can be dried in an oven after washing it. Yeah, so basically that is it. But if you want to understand more on salts, you check my channel, or maybe I'll remember to put something in the description. Yeah, Then B says suggest the name of other salts that can be prepared in the same way as lead to sulfate. So there's a way we remember. So lead sulfate is an insoluble salt. So we need to remember other insoluble salt. So there's a short way I use like this one, silclo and the balisu. So I use silclo and balisu, which means silclo, in it are salts like Si. I read it as silver, like this one is silver chloride. All right, so silver chloride is insoluble, so you can list, because they said suggest the name of another salt, so you can either mention silver chloride, or this L here means lead, so you can also say lead chloride. So even lead chloride, lead to chloride. Then I have this balisu, so Bm means barium. Then this one here, Le means lead, then Su means sulfate. So these are insoluble, like we have barium sulfate, which is the one already mentioned here, so we'll not mention it, but we can have also like lead sulfate. All right, what is mentioned here is lead, right? So barium sulfate, so we can mention barium sulfate. So these listed here, they can be prepared in the similar manner like lead to sulfate because they are insoluble salts. All right, so let's go to B5, which says calcium nitrate decomposes on heating according to the equation. This is the equation. You have calcium nitrate, right, decomposes on heating according to the equation, meaning to decompose is to break down. So meaning this calcium carbonate as one compound, when it is heated, it breaks down into these, like calcium nitrate is breaking down into calcium oxide, nitrite, and then oxygen. Then they're saying copy the equation given and balance it. All right, so it will be simple. You copy it the way it is, all right, then you start balancing it. So balancing equation is quite tricky but simple if you do it oftenly. So what you do, you check like how many calcium atoms are here, like we have one calcium atom even here, so calcium atom is self-balanced. Then you come on nitrogen, because there is a bracket here and a 2 outside here, it means there are 2 nitrogen atoms here. So that means nitrogen atoms, there are how many? They are 2. But when you come here, nitrogen atom is just 1. So meaning nitrogen atom, you need to balance them. So this side there are 2, even here you put a 2 so that they become 2. Then from there you come to oxygen. Oxygen, there's 3 here inside, it means there are 3 atoms, but also since it is inside the brackets and outside there's a 2, it means you say 3 times 2, which means in total 6, meaning you have 6 atoms of oxygen. Now when you come here, you have this atom here, 1, then you have these 2 times this 2 here also, because this 2 is also affecting oxygen, so you have like 4 plus this 2 here, you have like 5, then plus 2 here, you have like 7. So this side you have 6 atoms of oxygen, this side of the equation you have 7. So meaning you need to balance it. So how are you going to start balancing? Again, you are going to change. So since you have 7 in this side, you make the number of oxygen even. So like you put a 2 here to make them even. So on this side you have like how many now atoms of oxygen? 2 plus 4 here plus this, so you have something like 2 plus 4, 6 plus 2, 8. So you have 8 of them. So now here you discover, after putting a 2 here, you make calcium to be what? You make calcium to be 1, to be here calcium becomes 2, and here calcium is 1. So you need to balance calcium also by putting a 2 here. So when you put a 2 here, you make calcium also to be 2. So once calcium becomes 2, then you are good to go. But again, you need to recheck your equation. So what you do here is this. So you need to recheck your equation. So what you do, you see that calcium is 2 here, and here it is 2, okay? Then this 2 also affects nitrogen. So nitrogen was 2 here, that 2 times 2, it is 4. So nitrogen has become 4, but here nitrogen is still 2. So now this means that this balancing was not done well. So meaning you need to put a 4 here so that this becomes 4. So nitrogen needs to become 4 here, all right? Because here it is 2 times 2, 4. Okay, then you put a 2 there so that it becomes 4. Nitrogen, there are how many? 4. Then you check oxygen. Oxygen, there are like 3 times 2, 6. Then times that to 12. So oxygen is 12. You come this side, you have 2 oxygen. Then you have these 2 times 4 here. You have 8. So 8 plus 2, 10. Plus these 2 here, 12. So oxygen is 12. So you have seen that the equation now has a balance. But I'm sure there's another way of balancing it. All right, so this is the balanced equation. Then B, they said we calculate the relative formula mass of calcium nitrate. So we'll solve it here. So calculate the relative formula mass of calcium nitrate. So this is the formula mass of calcium nitrate. So you check from the periodic table the masses, because the formula mass just needs the addition of the total masses of each atom here. So the total mass of the atom of calcium, the atom of nitrogen, the atom of oxygen. So when you go to the periodic table, the mass of calcium, like here, you find that the mass of calcium, which is here, is 40, and that of oxygen here is actually 16, and that of nitrogen is 14. So here you find that the mass of calcium 40, nitrogen 14, oxygen it is 16. Then you say, okay, relative formula mass will be equal to, so you get this 40 plus, then you get this 14. Now you see that this 14 is for nitrogen, right? But there are 2 atoms of nitrogen because of these 2 outside the brackets. So what you are going to say, you say, okay, I have 14, but there are 2 of them, of this nitrogen. Then you say plus, you add, you want to add for 16 for oxygen. So you see that oxygen is 16, but because there's this 3 below oxygen here, so it means there are 3 atoms of oxygen, then times 2, there will be 6. So meaning you are going to say like 16 times 6. When you evaluate this, you find that the total atomic mass or formula mass will be like 164, and then it is not going to have units. Just leave it like that. Okay. Then next we move to question C, which says 16.4 grams of calcium nitrate is decomposed. Okay. So calculate the volume of oxygen gas liberated at room temperature and pressure at RTP. Then so we are told that let me bring the equation first. So this is the balance equation. We are told that we have 16.6 grams of calcium carbonate. So there is like 16.4 grams of calcium carbonate that gets to decompose to form these things here. Now they are asking us to calculate the volume of oxygen gas liberated at room temperature and pressure, which is RTP. So here you can handle this question the stoichiometric way. So according to stoichiometry, this is how this reacts. Like if you have 2 moles of calcium nitrate, they always give you 1 mole of oxygen gas. That's how they react. Or rather, if you want, you can say the relative formula mass of nitrogen here, I mean calcium nitrate, goes with that relative mass of oxygen here. Like here we found the relative mass of calcium carbonate to be 164, calcium nitrate. Then because there's a 2 here, you multiply it by 2 so that you get 328. Okay, so that you know that, okay, it's that mass at the equation level or stoichiometric level. This is the mass that reacts with the relative formula mass also of oxygen in this equation. It is actually 32. Okay, so at the stoichiometric level you need to have 328 to produce 32. Okay, that's what it is. But then you have been told that you have 16.4 grams of calcium nitrate. So then how much of oxygen gas will be produced in terms of that? So you say, okay, so if I have 16.4 grams of calcium, how much then of oxygen will be produced? You don't know. So you put an X here, then you cross multiply. So once you cross multiply, you're going to say 328 times X, you get 328, then equals, then 16.4 times 32, you get like 524.8. So like when you have this, your interest is to find the X. So you divide by 328. Okay, even this side 328. So once you do that, this will cancel, like this one and this one will cancel, so you remain with X is equal to, so when you divide 524.8 divided by 328, you get something like 3.2 grams. So in other words, at a microscopic level, or rather at a stoichiometric level, if you have 328, will always react with 32 of oxygen. Again, if you have like 16.64 of calcium nitrate, it will always produce 3.2 grams of oxygen. Now they want the volume, not grams. So then we'll know, for us to be able to know the volume, we need to know the number of moles then of oxygen in here. All right, so we need to know that number of moles is equal to mass over molar mass. Okay, then we know that the number of moles is going to be equal to, so we'll get in the mass that has been found of oxygen, which is here, we put it here over, then we know the molar mass of oxygen, we know that it's 32, oxygen gas is 32. So now what we do here is to divide. Now if you divide 1.6 by 32, you get like number of moles here, which will be like 0.05 moles. Okay, so now we convert this mole, all right, into what we call volume. Now since we are dealing with conditions of room temperature and the pressure, there's a condition. If you come on the periodic table just here, let us come on the periodic table. If you read this statement here, all right, let me try if I can zoom in for you. Let me try if I can zoom in. Okay, let me try to zoom up more again. Okay, so if you read this condition, which is already found on the periodic table here, it says the volume, okay, of 1 mole of any gas is 24 cubic decimeter at room temperature and the pressure. All right, so meaning that if you have just 1 mole of volume at this condition, in that 1 mole of any gas, you can find that it will have the volume of 24 cubic decimeter. You have 1 mole will give you volume of 24 cubic decimeter. Okay, then when you come to this situation at RTP, you find that this reaction will produce 0.05 mole. So for you to answer this, you say, but if I have 1 mole, I will have like 24 as the volume. What more this 0.5 will have? How much volume you put X? Then you cross multiply. 1 times x equals 0.05 times 24, you get like 1.2 cubic decimeter. All right, so meaning this is the volume of the gas that will be formed. So then you are going to say, therefore the volume of oxygen gas liberated at RTP is 1.2 cubic decimeter. That's so. Then let's proceed to B6, which says the following elements with their electronic configurations are in a certain group of the periodic table. All right, so these elements with this electronic configuration are in a certain group of the periodic table. So we have element W with just 2 electrons in the first shell, element X with 2 electrons in the first shell and 8 electrons in the second shell, element W, element Y, 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, element Z, 2 electrons in the first shell, 8 electrons in the second shell, 18 electrons in the third shell, and 8 electrons in the fourth shell. Then they're saying here, name the group in which these elements belong. Okay, so when you check these elements, they all have stable configurations. Like here, 8 electrons in the last shell, which is stable, 8 which is stable, 8 which is stable, 2 which is stable for the first shell. Then they say name the group in which these elements belong. So the group on the periodic to which you find elements that are stable is just group O. It's just group O. Okay. Then B, they're saying what accounts for the chemical and reactivity of this group of elements. Okay, so these groups, this group of these elements is unreactive, and what causes it to be unreactive is because the elements in this group have got full outermost shell. So we are going to say group O elements have filled up outermost shell, which means they don't need to participate in any reaction to become stable. Yeah, so that's why they are stable. All right, then the C, they're saying W is used in weather balloons. Explain why W is the most suitable for this use. All right, so weather balloons are balloons that are fitted with the weather instrument to just monitor the weather in the atmosphere, and these balloons float in the atmosphere. Now they're saying they use this one W to fill these balloons. So explain why W is the most suitable for this use. So the answer is that helium, because W is helium, so I just went direct to say helium is very light and also unreactive. Yeah, so it is light, so when you put it in balloons will be able to float, and because it is unreactive, those balloons will remain stable and won't have any problem in terms of maybe the gas reacting, exploding, nothing. All right, so let's move to the last part, which is D. Says describe the change in density as you go down the group. So when you are in group O, as you go down the group, something changes like density. So they are saying density. How does density change? So density actually increases. All right, so here we are saying density increases from top to bottom of the group. Yeah, so as you go down the group, the density of these atoms usually increases. Yeah, so they have to just increase, because density, if you see, density is equal to mass over volume. So as you go down the group, the atomic mass increases, and hence the mass number increases. And if the mass number increases, meaning mass here increases. All right, so if volume is also increasing but not at a bigger scale as mass, then you find that the density will also increase down the group. So this could be the best answer here. Then we go to B7, which says many carbonates decompose to form the metal oxide and carbon dioxide. Table 7.1 shows the mass of the carbonate before and after heating. Okay, so here we are provided with a situation where they're telling us that carbonates do decompose and they form metal oxides and carbon dioxide. And then they're saying this table here shows the mass of the carbonates before and after heating. So you have like carbonate, like you have, these are the carbonates, then you have mass before heating in grams, so these are the masses before heating. Then here you have like mass after heating, these are the masses after heating. So like you started studying, like you have the first carbonate, zinc carbonate, upon heating, after mass before heating is like 2.00 grams, then mass after heating is like 1.3 grams. It means it decomposes to form like zinc oxide and then the gas carbon dioxide, which goes into the atmosphere. Then copper oxide, again, when you heat, it decomposes as well to that mass. Then calcium carbonate also decomposes to that mass. Iron carbonate decomposes to that mass. Potassium carbonate, you have 2.00, here you have 2.00, so this one does not decompose. Then magnesium carbonate decomposes to that. Okay, then now they are telling us to say, write a balanced chemical equation for the decomposition of zinc carbonate. Okay, when we have zinc carbonate is decomposing, so we need to write the chemical equation. So we write zinc carbonate, this is how it is written. So if zinc carbonate is heated, like you put the gas symbol heat here, meaning it is undergoing decomposition, it will give you zinc oxide plus carbon dioxide. That's all. So this is the equation for the decomposition of zinc carbonate. Then you go to B. So B here, they're saying which carbonate is the most thermally stable. Give a reason for your answer. So bring the carbonates here. So they want the one that is thermally stable, meaning the one that does not decompose. Okay, so like we check the one that is not decomposing. Like if these are the initial masses, then these are the final masses. So like potassium carbonate had the initial mass 2 grams, final mass 2 grams. So it did not decompose, meaning it is thermally stable. So we are going to say potassium carbonate, and they're saying give a reason for your answer. We are going to say this is because the carbonate did not decompose on heating. Yeah, did not according to here, or does not decompose on heating. Yeah. Then we move to C. C is saying calcium oxide is produced on a large scale by heating calcium carbonate in a kiln. What environmental problem is associated with the large-scale production of calcium oxide? All right, so here we are dealing with calcium oxide, right? So remember in the question in section A, where we looked at the calcium carbonate being heated to form calcium oxide, that calcium oxide plus carbon dioxide. Okay, then that calcium oxide being like what to produce slaked lime. Now they're saying calcium oxide is produced on a large scale by heating calcium carbonate in a kiln. What environmental problem is associated with large scale production of calcium oxide? So here is just the concept that they're trying to test. The concept that you must understand, that when you are heating like calcium carbonate, it should produce the calcium oxide here together with the carbon dioxide, and that carbon dioxide has some environmental problem associated with it, which is global warming. So here in answering, you are going to say large production of calcium oxide leads to more emission of carbon dioxide gas, which contributes to global warming. Yeah. Then D, they're saying select the carbonate which on heating produces a compound which is used as a refractory material. So this is just magnesium carbonate. Okay, so it's magnesium carbonate here. Though in our syllabus, I think we don't talk much about this. Yeah, so that's why it is important to revise in past papers, so that you see which questions appear as a general question like this one, so that even in your study you must be able to generalize in your study, so that you study more. After you have studied what is prescribed in the curriculum or syllabus, then you need to study more, so that you have general knowledge about such questions. Like magnesium is the one that produces a compound that is known as a refractory material. So here a refractory material, here we're saying a refractory material is a substance that is resistant to high temperatures and is used to make heat resistant structures like kilns. Yeah, so that is it here. Yeah, so then we move to question B8. So B8 is saying three gases A, B, and C have properties shown in the table. So we have three gases. We have like gas A, B, C, and here are the properties like density: A more dense than air, B less dense than air, C more dense than air. Then solubility in water like A soluble, B soluble, C insoluble. Then appearance, they are all colorless. Then they're saying some apparatus used to collect gases are shown in the following diagrams. So we have this apparatus for collecting gases, this apparatus X, apparatus Y, then apparatus Z. Then let's go to the next question. So this question A says, which apparatus X, Y, or Z is mostly suitable to collect gas? Part 1 A, then part 2B. So here what they mean is this. So let's come to this point here. So they're saying which of these apparatus is suitable for producing gas, okay, most suitable to collect gas. So which of these apparatus here, X, Y, Z, is suitable for collecting like gas A and B? So when you look at these apparatus, this one is showing gas goes down, so this is downward displacement, and this one is showing also this one, the downward displacement is for collecting denser gases. So which gas is denser here? So the gas which is denser here is A. So like A will be collected by X, okay. Then this one here which goes upward is an arrangement which is used to collect a less dense gas. So a less dense gas here is B. So B can be collected using Y here. So when we come to the question here, we can say like apparatus X can be used to collect A, then apparatus Y can be used to collect gas B. Then B here says gas C can be collected using apparatus Z. So gas C can be collected using apparatus Z. So apparatus Z. So gas C can be collected using apparatus Z here. Okay. So now they are saying, let me just come in. They are saying state Y. Yeah, so they're saying gas C can be collected using apparatus Z. Alright. So this gas C can be collected using this apparatus Z here. Then they're saying state Y, apparatus Z is more suitable than apparatus Y to collect gas Z. So why is this apparatus here more suitable than Y? Okay, so you see, if you use Y and this Y is open, meaning the gas that will go there and get collected will be mixed with the other gases, so it will not be pure. So this one is suitable because the gas that you can collect here can be pure. So in answering, you can say apparatus Z ensures that only pure gas is collected. Yeah. So then we come to here, which says state Y, apparatus Y is more suitable than apparatus Z to collect gas B. So state Y, apparatus Y is more suitable than apparatus Z to collect gas B. So state Y, apparatus Y is more suitable than apparatus Z to collect gas B. Okay, so here this is the situation. So they are saying why is it more suitable to collect to use apparatus Y here to collect gas B. So when you look at gas B here, it is also less dense than air. All right, so it is less dense than air. So because of that, it can be collected even by this, the way this one is going upward, even this one is going upward like that. Then the same, but why is it more suitable to collect gas B using this apparatus than this? So you see, this is soluble, this gas is soluble. So because it is soluble, if you use this method and this is water, it will dissolve in the water and there will be no gas that you collect here. So in answering, you can say this is because gas B is soluble in water and using apparatus Z to collect it will be difficult as the gas will dissolve in water. Yeah. So the last part, which is C, says suggest a name of a gas that would be collected using apparatus X. Like which gas can be collected using apparatus X. So we usually use for collecting apparatus for collecting gas the gas we can collect using apparatus X is actually carbon dioxide here. So we can say carbon dioxide. So we go to B9. So B9 says the following diagram shows some of the reactions of ethanol. Okay, so this diagram shows ethanol, oxidation, solution P, process Q, it forms ethene. Then also we have here complete combustion, we have gas R. Yeah, so now they're saying draw the structural formula of ethene. We draw the structural formula of ethene. All right, so ethene is an alkene, right? Yeah, so it is an alkene with 2 carbon atoms. So structural formula, it should show the bonds. So in alkene, we have double bonds between carbon atoms. So since these carbon atoms are 2, so they'll have a double bond. And then since this is a hydrocarbon, it will have this one will have 1 hydrogen attached. So there'll be hydrogen here and that. So this is a structural formula. Then we go to the other part. So B, give the names of B part 1, solution P. All right, so let's bring this diagram here. They want the name of this solution P. Like if ethanol undergoes oxidation, then it forms solution P. What is the name of solution P? So this is ethanoic acid. So if ethanol undergoes oxidation, it forms an acid, and this is ethanoic acid. Then they're saying process Q. So which process Q? This one here. So if you have ethanol, then you end up having ethene. Then this process is called dehydration. So this is dehydration, like a water molecule is taken out of it. Then in gas R, like if ethanol undergoes combustion, what gas is formed? That gas plus water. I've told you it forms gas R and water. So that gas actually is carbon dioxide. So when ethanol undergoes combustion, it forms carbon dioxide and the water. Okay. Then C, they're saying write a balanced chemical equation for the complete combustion of ethanol. Okay, so they want a balanced equation for this complete combustion of ethanol. So you're going to write ethanol. The chemical formula is C2H5OH. So then plus, so combustion of oxygen gas, then that will give us carbon dioxide gas plus water. So we'll balance by putting it to somewhere here. Okay, because when you check in terms of oxygen, here oxygen atoms are 1, and then here when you check we have what we have 2, so 3. When we come to carbon atoms, here carbon atoms there are 2, then here we have 1. Okay, so we put a 2 so that they become 2 here. All right, then after we do that, we discover that when we come to hydrogen here we have 5 plus 1, here we have 6. Then here hydrogen we have only 2, so to make them 6 we put a 3 here. All right, so they have balanced. Then when it comes to oxygen, we have like oxygen here 1 plus 2 here 3. Then when we come here we have like 2 times 2 here 4 plus this 3 here, we have like 7, right? So here, in order to make them 7 here, also we put a 3 here so that there'll be 3 times 2 6 plus 1 here 7. So now we have balanced this equation very well. Okay, so then next we are going to go to section C. We are done with section B. Now we are on section C. So in section C, they are saying answer any 2 questions from this section in the separate answer booklet provided. So like C1, they're saying in an experiment. Okay, so there were 2 questions like this one and this one here. So we'll start like answering them. Okay, like section C1A. So this is the question here. So C1A, they're saying in an experiment to find the concentration of a solution of sodium hydroxide, 0.1 molarity of hydrochloric acid was run from a burette into a conical flask containing 25 cubic centimeters of aqueous sodium hydroxide until neutralization took place. Then the same 25 cubic centimeters of the acid was required. Then A part 1 says name a suitable indicator to use in this experiment. Okay, so this experiment is a neutralization reaction which happens between an acid and a base, and we have indicators that we use to indicate the end point of the reaction, or the point at which the neutralization occurs, or the equivalent point. Okay, so either we use methyl orange, but the most suitable one indicator in this case is a phenolphthalein. So here we are going to say the most suitable indicator is phenolphthalein. Then when we come to this other question, says describe the color change that would be observed when neutralization occur for the indicator you named in A part 1. So when we come to this indicator here, phenolphthalein behaves like this. So the color will change from pink to colorless. All right, so why am I saying it is changing from pink to colorless? So because when you put like you study, this is titration actually process. So in a titration reaction like this one, you will discover that they're saying in an experiment to find the concentration of a solution of sodium hydroxide, 0.1 molarity of hydrochloric acid was run from a burette. So meaning hydrochloric acid was run from the burette into a conical flask. So the conical flask had already sodium hydroxide. All right, so into a conical flask containing aqueous sodium hydroxide. So meaning this indicator I've mentioned, phenolphthalein, is first added to sodium hydroxide, and when you add it to sodium hydroxide, it is actually pink. Now the moment you start running into it hydrochloric acid, at neutralization point, that pink color changes from pink to colorless. All right, that's why I mentioned pink to colorless. Okay, so now we go to B. So B here, the question B here is saying write down the chemical equation for the reaction that takes place in the conical flask. Okay, so since you are mixing hydrochloric acid and sodium hydroxide, so that is the reaction we are writing. So we are going to say sodium hydroxide aqueous plus hydrochloric acid aqueous. So these two, a base and a salt, when they react, they form a salt, which is sodium chloride plus water. So this equation doesn't require to be balanced, as it is already balanced. Okay, then the other part of the question is saying like sorry, where are we? Here it is saying C1, how many moles of hydrochloric acid were used in the experiment? So they want moles of hydrochloric acid. So we want to calculate moles of hydrochloric acid. So for us to do that, we need to have this information. So okay, we'll say C part 1. If they want the moles of hydrochloric acid which were used, so we'll come to this point which says 0.1 mole of hydrochloric acid was run from burette into a conical flask containing 25 cubic centimeter of aqueous sodium hydroxide until neutralization took place. Then they're saying 20 cubic centimeter of the acid was used. So when you check, we have concentration and the volume. Then they are asking us to calculate the moles of hydrochloric acid. Okay, because they are saying, let me check again the question. They are saying how many moles of hydrochloric acid were used in the experiment here. So they want the moles. So now here, since we have volume and concentration and volume, so meaning there is a relationship between these two and the moles. So it is concentration formula, which is concentration is equal to number of moles over volume. Okay, so we need the number of moles, so we'll make number of moles is equal to concentration times volume. So we'll go to data. So you see that concentration is this 0.1 molarity and volume is this 20 cubic decimeter. So this volume, when we divide by 1000, it can change to 0.02 cubic 20 cubic decimeter. All right, so which is now here, sorry, this one should have been number of moles. Okay, so number of moles here is now unknown. Okay, so we'll say okay, number of moles is equal to concentration 0.1 times volume 0.02. so when we multiply this, we'll find that the number of moles will be like 0.0020 moles. So we are going to say 0.0020 mole of hydrochloric acid were used in this experiment. Okay, then we go to the next question. All right, so the next part of the question is part 2 here. Let me just get to read. So here part 2 saying, using the equation in B1, calculate the number of moles of sodium hydroxide. So they want us also to find the number of moles of sodium hydroxide. Now, if you go back to the equation that we balanced, here we just use the mole to mole ratio. Okay, so if we come, you'll find that the mole to mole ratio between sodium hydroxide and the hydrochloric acid in that equation is 1:1. Okay, so it is 1:1. What I mean is this: when we balance like sodium hydroxide plus hydrochloric acid, which gave us sodium chloride. This is a sodium chloride plus water. So don't mind this, can't write properly, it's not my issue. So here you find that we have 1 mole of sodium, and sodium hydroxide, and 1 mole of hydrochloric acid. So since they are 1:1, that's how they are reacting. That means that if we are able to know the number of moles of hydrochloric acid, that means that is the same number of moles for sodium hydroxide. Yeah, that's just how these things move. So we are going to say this means the number of moles of hydrochloric acid is equal to the number of moles of sodium hydroxide. So we are going to say, so the number of moles of sodium hydroxide is equal to 0.0020 moles. The one that we found by part 1 is the same here, all right? Then what is the other question? Okay, so let me see. It's like they're saying calculate the number of moles of sodium hydroxide. Yeah, so they are the same. Yeah. Then we have come to part 3, calculate the concentration of sodium hydroxide in mole per cubic decimeter. So now we are calculating the concentration of sodium hydroxide. Okay. Oh, so this one should be part 3 here. I think it's like I should have forgotten to number here. So they want us to calculate the concentration of sodium hydroxide. So concentration is the number of moles over volume. And then when we come to data, you know that we have number of moles already for sodium, and then volume. We know the volume that was used. Volume is 25 cubic centimeters. So when we come here, you find that we are told like there was like 25 cubic, like 0.1 mole of hydrochloric acid was run from a burette into a conical flask containing 25 cubic centimeter of aqua sodium hydroxide. So this is the volume 25. So here we know the volume is 25. Now they want concentration. Then we change this volume, which will be 0.025. Then the concentration is unknown, so substitute equals volume. Number of moles is already found, 0.0020 over then volume 0.025. When you divide this, you get like 0.08 molarity. So this is then the concentration of sodium hydroxide. So we are going to say the concentration of sodium hydroxide is, because they said you put in a mole per cubic decimeter, so you say is 0.08 mole per cubic decimeter. All right, then we move to the next question, which is D. All right, so when we come to D here, D1 says give a reason why the burette was used to determine the volume of the acid and not a measuring cylinder. All right, so here it has to do with the accuracy. So part 1, we are going to say because a burette measures volume more accurate than a measuring cylinder. Then part 2 here, says how was exactly 25 cubic centimeter of sodium hydroxide transferred into the conical flask. How was this transferred into a conical flask? So here we are going to do like this. So here the answer is that here we are going to say sodium hydroxide was transferred using a pipette, which was filled and emptied using a pipette dropper or pipette filler. Okay, so that's the answer. Then we go to C. 2C2 says nitrogen and argon are both elements found in air. So nitrogen and argon are both elements found in air. All right, so let's check these elements. So argon and nitrogen are both elements found in air. So A, they're saying draw the electronic structure of nitrogen and argon. All right, so for us to draw these, it would be simple. Okay, so part 1, A1, they're saying we draw electronic structure of nitrogen. So electronic structure for nitrogen will be like this. So when you go to the periodic table, nitrogen will be represented by this, which means it has 7 electrons, which can be put in shells like the first shell 2 electrons, the last shell 7. So meaning in terms of electronic structure, you put them in shells like the first shell of nitrogen will have 2, then the second shell will have like 5 of them. Then electronic structure of argon Argon on the periodic table, it has 40, 18, meaning which will sit like 288. Then in shells, there will be like in the first shell 2, like these 2 in the first shell. Then the second shell will have 8 like that. Okay. Then the third shell will have also 8 like that. Okay. So we are done with part 1. So we'll go to part 2, right? So we are done here, which says draw the electronic structures of nitrogen and argon. Then B, with reference to the electronic structures in part 1, explain why nitrogen and argon are found in period 2 and 3 respectively. Like using the electronic structures, we need to explain why argon and nitrogen and argon are found in period 2 and 3 respectively. So like why nitrogen is found in period 2 and why argon is found in period 3. Okay, so simple again here. So here we are going to say the number of shells in an atom is equal to the number of period the atom belongs to in the periodic table. Hence nitrogen is found in period 2 because it has 2 shells, and argon is found in period 3 because it has 3 shells. Yeah, so you see here is the issue. So since nitrogen has 2 shells, like 1 shell and 2, then it will be in period 2. Then argon has 3 shells, like 1, 2, 3, then it will be in period 3 like that. So this is why we had to put in this as the answer. Then we have C. Per question C says the diagram, the flow chart shows the separation of nitrogen and argon from air by fractional distillation. Okay, so we have like filtered air, then undergoes process X to form liquid air, which undergoes process Y to separate liquid air into nitrogen gas at negative 196 degrees Celsius and into argon gas at negative 186 degrees Celsius. Then part 1 is saying describe the process that take place at X and Y. So what process takes place at X and Y here? So this is how we describe. It says at X, filtered air is liquefied by compressing and expanding it several times in compressors and heat exchangers. Okay, so that's what happens. So at X here, we are saying filtered air here, when it passes at X, it is compressed. All right, so it is compressed and expanded several times. Okay, it is compressed and expanded several times in compressors and heat exchangers, so that it becomes liquid air. Yeah, then we are saying at Y, liquefied air is separated by fractional distillation, which involves heating the liquefied air and passing it through a fractionating column where nitrogen and argon boils off at different temperatures and collected separately. Yeah, so this is what happens. So at Y here, what happens is that this liquefied air now is now separated by fractional distillation, which involves heating this liquid, so that and then passing this liquid, the vapor, into the fractionating column, and in that fractionating column the nitrogen and the argon will boil off at different temperatures and collected separately. Yeah, so those are the processes there. So now we go to part 2 here. So part 2 here says give one use of nitrogen gas. So nitrogen gas has got so many uses. Okay, so we had like it is used in the manufacture of ammonia by Haber process. So you can also say it is used as a refrigerant, it is used as a coolant. So these are some of the uses of nitrogen. Then the other part of the question here is this one saying D, argon is a liquid at negative 188 degrees Celsius. Then A, they're saying in what state we are going to be at 5 degrees Celsius. Yeah, so if at negative 188 degrees Celsius, it will be like at liquid state. Then for you to move this negative 88 to positive 5 degrees Celsius, then this gas will actually, this argon actually would have actually changed from liquid, then it will go to gas. So it will be in a gaseous state. So when they say in what state we are going to be at 5 degrees Celsius, it will be gaseous state. So you say here that D1, you say gas. Then in 2 here they're saying draw a diagram to show how the atoms of argon are arranged at 5 degrees Celsius. So in gas, this is how it is going to be. So this is the diagram they are asking you. So you can name this as gas atom argon atoms. Then we go to the last question, which is the C3, which says ethanol is a product of many fermentation reactions. The molecular formula of ethanol is C2H5OH. Then one, they're saying draw a displayed molecular structure of ethanol. All right, then yeah, so let's just start answering than reading the questions. So these are the questions here and these. So let's go straight into answering the first one, which was asking us to draw the structural formula for ethanol. So this is it. So ethanol is like this. So the structural formula will be like ethanol, and there will be a bond here. Then there will be a bond where we'll connect this. Then a bond here. So we have put 2 carbon, this one as the skeleton. Then we join to them some these hydrogen and hydroxide. So here we'll have another one. So here we'll put these 5 hydrogen, like here. Then this side will come, or H will come here. So this is the displayed structure. Then in the other part of the question is here, like B, when ethanol is heated with potassium dichromate 6, it is converted to ethanoic acid. Then B1, what type of reaction is this? So this type of reaction here, one is called oxidation. All right, so it is oxidation which leads to the formation of ethanoic acid from ethanol. Yeah. Then part 2 here, the question says give one safety rule to be observed when handling ethanoic acid in the laboratory. So since ethanoic acid is an acid which is very deadly, so you need to apply laboratory safety rules that are very common. So like the one that were listed here is this. We said one safety rule observed when handling ethanoic acid in the laboratory is to wear appropriate personal protective equipment, PPE, such as gloves, goggles, and lab coat. Yeah, so when handling these, make sure one puts on gloves, put on goggles, and also lab coat to make sure that there's safety when handling ethanoic acid. All right. Then next, you can also mention the mask here. The mask can also be important. All right. Then next, we go to this other part of the question, which is the part of the question, which is this one here. See, says the ethanoic acid reacts with the ethanol in the presence of a catalyst to produce a new substance. Give the name and deduce the formula of the new substance. Okay, so we need to give the name of the substance formed when ethanoic acid reacts with the ethanol in the presence of a catalyst, and then we give also the formula. So here, when we have ethanol reacting with the ethanoic acid, it will form an ester which is ethyl ethanoate. So this ethyl ethanoate has a formula like this. So this is just the chemical formula for ethylethanoate. Yeah. So if you get the biology, the organic revision package that comes with the science revision package going at 120, then you will be able to come across these things where I explain how to drive such chemical formula. Then in the other part of the question here is this here. So what would be observed when aluminium is added to ethanoic acid? Give a reason for this observation. Yeah. So here, this here is the answer. So the rate okay, so we are here, right? Yeah, they're saying ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium to liberate hydrogen gas. Then they're saying D1, compare the rates of reaction of ethanoic acid with sodium and magnesium. Yeah, so you must understand that sodium is in group 1, it reacts faster of course than magnesium, which is in group 2. So in answering this one, you say that the rate of chemical reaction between sodium and ethanoic acid is much higher than that of magnesium with the ethanoic acid. Then part 2 here says what would be observed when aluminium is added to ethanoic acid? Give a reason for this observation. All right, so here we are saying a white precipitate is formed and fizzing or bubbles are observed. Okay, so this is why, because a precipitate of aluminium aluminium salt is going to be formed. Yeah, I think I left out the reason here. Give a reason for your answer. They're saying what would be observed when aluminium is added to ethanoic acid. So what will be observed when aluminium is added to ethanoic acid? We give an explanation, give a reason for this observation. So I'm going to explain, like there will be like a fizzing or bubbles are observed, and the reason why bubbles are observed is that aluminium being a metal displaces hydrogen from the ethanoic acid, all right, and then forms what is known as aluminium acetate. So those bubbles that are observed are bubbles of hydrogen that is produced. Yeah, so that is the reason why there's a fizzing and the bubbles are observed, or a white PPT, which is just aluminium acetate. All right, then like the other part of the question here is like give one reason of aluminium based on okay, give one use of aluminium based on the observation made in one. So based on that observation, we can say aluminium is used as a catalyst, and it can be used to produce hydrogen gas. So it can also be used to produce hydrogen gas here. So hydrogen gas. Okay, and it can also be used to produce aluminium acetate, which has various uses in real life situation. Yeah, so guys, we have come to the end of this chemistry or science paper 2 revision. I hope you enjoyed it, and if you did, you should have given this video a like, and you should have subscribed to the channel. If you have not, go and subscribe, because you are going to miss a lot. You miss the revision package, I mean the prediction that are going to come for GCE science paper 1 and paper 2, and also GCE biology paper 1, I mean biology paper 2. So subscribing to the channel is very important, because it will enable you get notified whenever I produce new videos. So it is for your own benefit. All right, so guys, bye, and see you in the next lesson, or rather next revision.